Good day, my students. You are welcome to revision classes organized by University Press PLC on mathematics. The classes are organized to equip you or empower you for the forthcoming examinations so that you will be able to answer all the questions on mathematics, both papers 1 and 2, with ease. My name is Akabisande Olusegun, and the materials we are going to use are textbook, the worthy ones made by authors, reputable authors that are seasoned examiners and teachers. And that textbook, I'm also part of it, is Mathematical Association of Nigeria, the textbook written by MAN, Mathematical Association of Nigeria. This is the textbook. You have been using it for quite a long time, and in fact the topics we are going to look at today cover almost 1/3 of the syllabus, and they are all here. For revision purposes, you will discover that more than 40 pages in the book are devoted for that topic. Thank you, and you will enjoy the efficacy in what we are going to discuss. The topic is algebraic processes. Algebraic processes. All from the word algebra. From the word algebra, you will agree with me that we are going to deal with letters. We are going to represent numbers with letters. You are going to represent quantities with letters, and you are going to find the unknown. But the first thing is, I am very, very convinced that if you are familiar with book 2, mathematics for senior secondary school, the first chapters 2 and 3, they are devoted for introduction to 1. Simultaneous equation involving two variables, linear equation involving fractions. But because we are revising, I want us to discuss quadratic equation. Quadratic equation. Quadratic equation and function. Equations and functions. Quadratic equation and functions. Expression of this type, ax squared plus bx plus c. This is not an equation, is quadratic expression. The reason why we call it quadratic is the highest degree is 2. This is the first number here, which is a constant term, and it's called the coefficient of x squared. This b is also a constant term, is the coefficient of x, while c is an arbitrary constant. This is quadratic expression, not quadratic equation. But if I write ax squared plus bx plus c equals 0, this is quadratic equation. To find this value, the value of x is referred to as a variable. Is variable. It has so many values. Here, you are going to look for 2 values of x because the highest degree is 2. There are methods of factorizing quadratic equations. There are methods of solving quadratic equation. I will only give you 2 or 3 methods of factorizing. Methods of factorizing. The first one is direct method. This is direct. Then the other one, completing the square method. Completing the square. When you factor, if quadratic expression has factors, it may have rational factors, it may not have rational factors. If it does not, if quadratic equation does not have rational factor, you can't factorize it. There's no way. But we are only going to factorize quadratic equation that has rational factor. That has rational factor. I'll give you an example. Look at this. 2x squared plus x plus 11. If you have to factorize this, you may find it difficult to get the rational factor. Why? I will explain that when I get to what we call discriminant. That is what determines factors. What determines factors. But if you look at this, x squared minus x minus 2. This one has rational factors. Now, the coefficient of x squared is 1. Therefore, you don't need to use any other method. Just look at it directly. Look at the constant term. The constant term here is minus 2. Steps to be taken to find the factors. Step 1. Find 2 factors of minus 2 such that when added it gives coefficient of x. Please take note. The coefficient of x squared, let me write it down for you. The coefficient of x squared is 1. Coefficient of x is minus 1. This one is the same thing as minus 1 times x. Constant term. Is minus 2. Now, the step says find 2 factors of minus 2 such that when added it gives coefficient of x. The 2 factors of minus 2 are either 2 minus 1 or minus 2 and 1. Please, without wasting your time, when 2 and minus 1, when the 2 of them are added, you get 1. When minus 2 and 1 are added, you get minus 1. Therefore, for this one, at your level, you say x squared. You say x squared minus x minus 2 is the same thing as x, put a bracket, put another bracket, a bracket, and another bracket. Now the two factors of minus 2, they are minus 2 and 1. So this one now will be x minus 2 and x plus 1. Now you conclude x squared minus x minus 2 is the same thing as x minus 2 multiplied by x plus 1. This textbook, you know, as I was saying the other time, if you open to page 162, if you open to that page, there are plenty of them. I don't want to waste your time. Let's look at another example. You will agree with you, you'll be wondering, what of if the coefficient of x squared is not 1? What are we going to do? I will explain. It's there. Now, if the coefficient of x squared is not unity, is not 1, the ways of handling it is this. Let's look at this. 2x squared minus x minus 3. The coefficient of x squared is not 1 but 2. You can use the Deformer method. The first method is the first step. Step 1. Multiply 2x squared by minus 3. That one will give you minus 6x squared. That is 2x squared multiplied by minus 3. Now the second step. Step 2. Find factors. That is 2 of minus 6x squared, that their sum gives minus x. You will be asking, why minus x? The reason is this. This is 2x squared minus x minus 3. You know, this is minus 6. These factors of this, two factors of this, that will give this. Why? When getting those two factors, you substitute for this value. This is what I'm saying. Minus 6x squared. Minus 6x squared. The two factors. If I were you, because you may be thinking, what of 1 and 6? What of 6 minus? No. Because this one is 1 here, you think of 2 and 3. Not 6 and 1. Because when 6 and 1 are added, there's no way you can never get 1. So the two factors are either 2x and minus 3x. You will be wondering, okay, what of minus 2x and 3x? If I were you, the value here is negative. Therefore, the bigger of the two must carry a negative sign. If the sign here is positive, the bigger of the two numbers must carry a positive sign. So in that case, substitute (2x minus 3x) for minus x. Please take note. That means this equation now becomes 2x squared minus x minus 3 will now be 2x squared plus 2x minus 3x minus 3. Please look at this. 2x minus 3x is the same thing as minus x. So you are not destroying anything. The only thing we are trying to do, because I will refer you to more mathematics for GSS 3, though it is not here, for GSS 3, chapter 2. We have factorization of quadratic equation. It's been introduced to Becker students. Look at this. We have 4 terms. 1, 2, 3, 4. Then you group. 2x squared plus 2x minus 3x minus 3. Then you group this one. Boys and girls, if you want to put a bracket here, for God's sake, this sign changes. For God's sake, if you introduce a bracket here, this sign changes. Please take note. Let's continue. Add 2x squared plus 2x minus, I put this one in bracket, 3x plus 3. We are now very free. Factor it out. Look at common factors here is 2x. You remember GSS 2 mass. 2x, this is x plus 1 minus, take 3 out, x plus 1. Getting to this stage, there is still a common, this and this. This one is common to this expression and this one is common. Take it out, x plus 1 in bracket. So this one remains 2x, then minus 3. So you see, therefore, 2x squared minus x minus 3 is the same thing as x plus 1 and 2x minus 3. I don't want to waste your time there. You see, I use this. Please take note. It's equivalent to. Please take note. Because at times they may ask you to equate both sides. If this is equal to this, you write it like this. Though if equality is there, then they'll pardon them, or you may be pardoned if you write that in the exam. But take note, we normally write it like this. Now, we are still on factorization. The other method is completing the square method. As completing the square method, then let's look at difference of two squares. Difference of two squares. Difference of two squares. Honestly, look at this. If you are asked, what is 7 squared minus 2 squared? You are very common. You take your calculator and then you do it. But there is one way you are taught. I want you to, that is why I said the other time, you have to familiarize yourself with all our textbooks, the mass. The difference of two squares was introduced in mass JSS 1, but in a funny way. Like this is the same thing as 7 minus 2 into 7 plus 2. We say, how? If I were you know 7 minus 2 is 5, 7 plus 2 is 9. What is 5 times 9 is equals 45. This one is 49, 7 square is 49, 2 square is 4. 49 minus 4 is still 45. From there, I want to give you the general rule. The general rule says a raised to power 2 minus b raised to power 2, because this is a perfect square, this is a perfect square. The answer is A minus B multiplied by A plus B. A minus B multiplied by A plus B. Now, you will be wondering, what are we going to do with this? This is, but in algebra, it is not difficult and it is not as simple as that. Let's look at this. Then we have to factorize. Because it's very common when you say a question, some of you will be thinking, what do they mean? Look at this. They say factorize. Factorize. Y squared minus 49x squared. Y squared minus 49x squared. 49 is a perfect square. So this is the same thing as y all raised to power 2 minus 7x all raised to power 2. This is difference of two squares. Then the next thing is to say y minus 7x multiplied by y plus 7x. That is all. Another one. Let's say we are asked to factorize again. Factorize. You will be thinking this is not difference of two squares. It looks like that, but it is difference of two squares. You have to do one thing. You know this is 2. It's not a perfect square. 18 is not a perfect square. But when you take 2 out, this one remains 1 minus 9 bracket x minus y all squared. Note this is still the same thing as bracket. But please don't use this and this or this and this. Now from here, 2 in bracket, 1 is 1 all squared, minus 9 is 3 bracket x minus y all squared here. Now we are after two different perfect squares. This one is 1, the whole of this one is another one. By that rule is the first one minus the second one, that is 1 minus 3 into x minus y multiplied by the first one plus the second one. 1 plus 3 into x minus y. You have to be very careful to close the bracket. Now simplify. 2 multiplied by 1 minus, open this bracket, minus 3x minus minus is plus 3y into 1 plus 3x minus 3y. Close the bracket. Finally, is now 2 into 1 minus 3x plus 3y into 1 plus 3x minus 3y. That is how to factor this one out. It's still difference of two squares. Now, we are still on algebraic processes. It is possible. That is why, because of our time, if I intended to answer as many questions as possible, we may be there for the next 3 days. But I want to refer you to this our textbook, the mathematics for SS3, page starting from page 1 to run through page 1, 2, 3, 4, 5. up to 161 to 167. 161 to 167. Now, the application of this, I will write down two questions. We look at them. One year they ask you, find limit of x squared minus 4, everything divided by x minus 2 as x tends to 2. They write the question like that. You know, the student will just, because they ask you as x tends to 2, then it is very common to say, okay, this is 2 minus 4 all over 2 minus 2, and you get 0 all over 0. I picked this question from UTMB 1 year. The alternatives are, they said A, they say find x. Then they say alternative A, you know, multiple choice. They say A, 0, B, 2, C, 1 over 4, D, half. The student won't bother. Immediately they see this 0, they pick it straight. Whereas the answer is not 0. The answer is not 0. That is why we have about 5 of them. I think pages exercise A2 in this book. A2, page 163. Page 163. Page 163. Now, this is not 0. You pick. If you substitute directly, you get 0 over 0. There's nothing like 0 over 0 in mathematics. This is not defined. This is not defined. The first thing they want you to do is this. Look at the expressions. X squared minus 4 all over x minus 2. Look at this expression. This is difference of 2 squared. It will be x minus 2 into x plus 2. Everything divided by x minus 2. Then this one, cancel this. Then it is x plus 2. Now, x plus 2. Then this is common. So the result is x plus 2. And the question says, when x approaches 2, you have to simplify. Then you substitute for x equal to 2. Look at the alternative. Which of the alternative is correct? None. 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 It is UTME. And I won't mention they don't put, so they put this one there to catch you. What they want you to do is find the factor of the two squares, simplify, and get then substitute. Substitute. It is not that. Now look at this one. This one is a typical questions given by WAEC. Typical questions given. The question says. The question says, for what values of x? For what values of x? For what values? For what values of x is the expression? X minus 5, everything all over x squared minus x minus 12. The first question. For what value of x is the expression? This one, number 1, 0. The second question, undefined. 6 marks by WAEC. 6 marks. There is a question mark here. For what values of x is the expression this one 1, 0, 2 undefined? I will work it and show you how we normally look at them when we work. You don't just the first one 0. The expression given, the expression x minus 5 everything all over x raised to power 2 minus x minus 12 is 0 when the numerator is 0. That is x minus 5 equals 0. Now, for saying x minus 5 equals 0, you are using the correct method. They give you M1. Therefore, x equals 5, A1. Please, you don't jump directly and say x is 5. You have to equate the numerator to be 0. That is why you are given M1. Then to say x is 5. Now, the second part, undefined. You know that I told you is 6 marks. That's 2 marks. Undefined. The expression. The given expression x minus 5 everything over x squared minus x minus 12 is undefined when x squared minus x minus 12 equals 0. That is when the denominator is 0. For recognizing that that is the first step, M1, there is no way you have to factorize this. You can solve this one. Factorize x minus 4 x plus 3 equals 0. You are factorizing. And for factorizing, for knowing that these one has rational factors, x minus 4, x plus 3, they say B1. For knowing that when two factors are multiplied together and the result is 0, and you are saying x minus 4 is 0, and x plus 3 is 0, they give you another M1. Then for saying x is 4 and x is minus 3, they say A1. This is 1, 2, 3, 4, the other one 2, making a total. This is x minus 4. And this x is equal to minus 3. Please, there are some textbooks they will say x is equal to 4 or we normally accept, but please, we are looking for 2 values. It is not this or this. It's supposed to be x is 4 and x is minus 3. X is 4 and x is minus 3. It's still the same thing. They may consider it x is 4, comma, then x is minus 3. Or you say x is 4 and x is minus 3. Now, Let's continue. The other, I told you, when you have quadratic expression ax squared plus bx plus c, if you equate it to 0, I said this is quadratic, it becomes equation. The value of x are minus b plus a minus the square root of b squared minus 4ac everything divided by 2a. This is what you normally call almighty formula. It's not almighty but quadratic formula. If in the exam, I want to give you a question similar to what we have in page 164. It's still one questions. Check. The question says find x to one decimal place. X minus 2 all squared equals 3. Now, this is the difference of 2 squared. You can take 3 to the other side, and there are two ways. You either open the bracket. If you open the bracket, this one becomes, the whole thing becomes quadratic equation. Because this one will be x squared minus 4x plus 4 equals 3. And this is x squared minus 4x plus 1 equals 0. This is quadratic equation. Or the other method, look at this. This is raised to power 2, this is 3. This is still the same thing as x minus 2 all squared equals 3. Find the square root of both sides. The square root of both sides, this one will disappear. X minus 2 will be equal to the square root of 3. Please, this one should be plus or minus, because the square root of a number is either plus or minus. Now, x, our x will be equal to 2 plus or minus the square root of 3. This is either 2 plus the square root of 3 or 2 minus the square root of 3. 2 plus the square, if you are asked to leave your answer in short form, you leave it like this. But in that question, why it says to one decimal place. So this one, 2 plus root 3, 2 plus root 3 is the same thing as 2 plus 1.732. Because the square root of 3 is 1.732. So this is 3.732. To one decimal place, this is 3.7. One decimal place. And if it's 2 minus root 3, you know there are two values. 2 minus root 3. 2 minus root 3 is the same thing as 2 minus 1.732. And that one will be 0.268. If you subtract this from this, 2, that is 0.268. Now, to one decimal place, that is 0.3. Now let's go to marking. Please, for God's sake. This is quadratic. For find square root of both sides correctly, they will say B1. B1. Let me B1. for carrying out the substitution and getting 2 minus root 3 or 2 plus root 3, another bonus mark. For substituting correctly, they will say M1. Then 3.7, this is where we are going. They said if you stop at this, you cannot get this one. It is true. The approximate value of this is this. But if this one is not seen, this one will be 0. So it is M1, A1 for 3.7, A1 for 0.3. And you get your full marks of 5. And if you use, because it's more or less this thing, if you solve this one, you will arrive at this. So that is why don't panic. If your friend is using the formula or this one directly. Now, well, the next lesson we are still going to continue and consider questions or problems leading to quadratic equation and quadratic function. Thank you for listening. I really thank the publisher for allowing us to use this textbook because it's of tremendous asset. All the questions, honestly, if you pick from pages 1 to page 162 to 170, it will keep you busy, so that if wire come or neco come from any angle, you will be able to meet them there. Thank you.